Hello, I'm David Redmond, and Paul Dorr is holding the camera right now. You'll see him later. This is our University of Michigan EECS 373 Fall 2012 final project called Real D Pong. It's basically a game of Atari Pong, but with real live mechanics. And so here's a quick demo before we get into the specifics of it. Huzzah!
Score.
Alright, so basically we use this SmartFusion FPGA comboed with ARM Cortex M3 processor to basically power the entire board and everything you see here. The power supply that we have here, 12 volts, supplied power to the board, which then powered everything else. The main concept on our project was this N64 controller, which we had to parse using, they use a similar to Manchester encoding type thing, receiving and sending signals on a single data line. And so once we got that down, the whole project started getting in motion. Now I will hand it over to my partner Paul so he can explain some other things.
Okay, so a big part of our project was getting our DC motor, which drives the belt here, and our solenoid to work properly. And of course we used the big power supply to provide all the power we needed to run those. And our power circuitry right here is a relay to switch our solenoid, and that allows us to control our big amperage voltage signal with our board without damaging anything, and an H-bridge, which gives us variable speed control of our DC motor for precise control of our paddle.
Could you show us which one's the relay and the H-bridge again?
This is our H-bridge, and this is our relay right here. And we have a similar setup on the other side.
And by similar, he means exact.
Right. Another part of our project is our LCD screen right here. It is our control station, basically.
Thank you.
As you can see, it allows us to start a new game. It gives us settings for different game modes. We can play with a time limit. We can have a score limit and set both of those. And once the game has started, it will count down and give us
Power,
a score.
Basically. Our motors and solenoids and scoring do not trigger unless the game is started. So
That is correct.
we also have a laser over here that basically shoots a beam out, and when it senses the ball in front of it, it will trigger the solenoid to punch. So so we got that going for us.
And that also controls our scoring. So when it sees that the ball has passed and has not come back, it can add a score point to our board.
And yeah, that is the basic concept of our entire project. We used SmartFusion to power all of this fancy things you see here with the very eloquent wiring of my partner Paul. And the board was put together with wood. It is mainly a prototype for this class. If we were to ever make this for manufacturing, we would.
So it is not perfect. The
Yeah.
ball can get stuck in the middle.
Yeah, the ball is very far from perfect. It's a very cheap ping pong ball that I bought for $8, so it doesn't make sense. But hey, what are you gonna do in college town? So we're gonna play a little more for you, so you can see the whole thing in action. And there's that perfect ball rolling great. And we scored one. Aha! I scored again.
That was
Sorry,
another
we're good at
miss.
this. Yeah, another ball.
Yeah, we are not
We got
very good
the
at this.
Alright, here we go.
It's a fairly challenging game because
We're holding
your
a camera.
ability to score is limited by the speed of the motor. And your ability to block scores, of course.
And Paul's motor's faster than mine, so that's cheating. I scored
That's
again.
true.
Alright, so what should the score tally be right now? 2-1. Huzzah! 2-1. And that is our project for EECS 373, Fall 2012, University of Michigan. Real Deep Pong in retailer stores soon.
Thank you for watching our video.